Hello everybody and welcome back to your video notes. It's Mr. Basil once again, and we're going to be talking about learning target 3.5, the meets level. The previous video we went over freefall velocity, and this time we're going to be going over freefall distance. And the meets level, the main thing that's going to differentiate that from the basic level is when the velocity at the beginning, the starting velocity, is not equal to 0. So it could be moving up, could be moving down, whatever. In the previous one, we went over this problem, and we only solved it for how fast it was going at the end. And we want to know is how far did it travel before splashing. I copied and pasted the. Come on, no. I'm trying to move the screen. Oh, there we go. I copied and pasted the problem over here, so we had a kind of a fresh start. So if you had this copied down from last time, don't really need to do anything else except add in how far did it go before splashing. Let's see, what color should we start with? That one seems good to me. So the equation that has how far, or like distance or displacement, you should be familiar with this already, but in case you aren't, you got this equation: d equals that's going to be the one we're working with, where v1 is the starting velocity, t is time, half is half, negative 9.8 we'll use for free fall, but acceleration could go there. And then this is time as well, but in this case you'd have to square your time. And then this stands for displacement. Which is that. And remember, displacement is just distance. It's kind of like distance, except it can be negative. Okay. All right. It's actually, so if we actually want to know what displacement is, so displacement is where you are to where it's where you are compared to where you started. So if I start here, I go up, and come back down, the displacement will just be from here to there, if that makes sense. If I'm here, I go up and then I go down, displacement will be there, in which case it would be negative. Okay, anyway, let's get on with the problem. So we know that the starting velocity is this, so here are givens and unknowns. Let's just start there. We want to find our displacement. So all those are the same as before, but now we're just going to plug it into this equation this time. Okay, now I'm just going to start plugging in our values. I like rewriting 1/2 as 0.5, because then it's harder to make calculator mistakes. Okay, so here we go. Let's start by crossing out some things. So seconds cross out there. This ends up becoming seconds squared. Seconds squared. So second squared and second squared going. And I'm just left with meters plus or minus meters, which is good because our distance and displacement units are meters. Now our order of operations, we got to be careful with order of operations. First thing we're going to do is square this right here. So 2 squared, that's the same thing as 4, right? And now we're going to do all of our multiplications separately. So we'll kind of go separately, and then we'll either add or subtract based off of what we got. So 15 times 2, that's 30, but the negative sign, can't forget about that. Meters is what's left over there. We've got plus, we got this whole business over here. So 9.8 times 4 times 0.5, 19.6, but I've got a negative in there. And meters are the only units that are left over after all that mess. So I end up with 30 and 19.6. We get 49.6, but both are negative. Like that, and meters for our units. So that means that they started up here, they threw it straight down, and then it went down 49.6 meters. Which makes sense, right? If you throw something down, it's going to move down. Alright, so there we go. Big things to watch out for here is making sure that you square your time. That's a very common mistake. And then just remembering that this meters per second squared business here, that's just a unit. You don't actually do any squaring with that. Don't forget your negatives. That's a common mistake I see all the time. And remember your order of operations. So do all of your multiplication first, and then do your adding and subtracting. Alright, for the next one, this was our original. This was our original one. So the ball is thrown upward at a speed of 20 meters per second. And then we wanted to know how fast it was going after 4 seconds, but we want to know where is the ball after 4 seconds. Okay, now if we go back to over here, remember that we said that the final velocity was negative 19.2 meters per second. If it started at positive 20, if it ends up at the same spot, it would be going the same speed, but just in the opposite direction. It would be going negative 20. So we guessed that in the last one that it's going to be a little bit above where we started from. Okay, so we want to figure out what the displacement is. So we're going to use that this equation, this guy, but then we're going to apply it here. Okay, see if you can do it on your own. Go ahead and pause the video because I'm going to be showing the answer here in 3, 2, 1, and there we have it. So I ended up with positive 1.6 meters. Now the way I got that is my starting velocity was 20 meters per second, positive 20, because again thrown upward, times 4 seconds, so it's like before, and acceleration as always is negative 9.8. Now the way this works is, got our equation here, I put in 20 meters per second for V1, and then T, I just did 4 seconds, and then plus the 0.5 instead of 1/2, the negative 9.8 meters per second, and then the 4 seconds squared. Now, again, remember, make sure that you do the 4 squared first, because that's the, again, big one that people always forget, that little squared factor there. And then I just checked all my units here, so seconds, crossed out seconds there, and seconds squared, and then 4 seconds squared. All of this is squared, so really I'd end up with 16 seconds squared, but those end up crossing out, so then I'm left with meters here and meters there. And then 20 times 4 gave me 80. All this multiplied got me negative 78.2. So then I ended up adding a negative. So really I subtracted 80 minus 78.2 and I ended up with, hey, how about that? 1.6 meters, which is what we predicted. We'd be somewhere just above where we started from. So this just means that we ended up 1.6 meters above where we began. Now, here's the interesting thing. If I ended up with negative, that's not the actual answer, but if I ended up with that negative there, what that would mean is that I would be, somewhere down here. It somehow went through the ground and I ended up here at the end, but that's not what we got, because that wouldn't make sense. All right, thanks for listening.